Okay, sometimes the numerator's exponent is less than the denominator. So if I check this one, the denominator is x squared, the numerator is x. X squared is greater. When the denominator is greater than the numerator, your limit will eventually go to 0. So if the denominator is greater than the numerator, your limit will eventually be, and will be 0. Okay, the next example has a plus and a minus. So all we need to do is cut it and do it separately. So I'm going to look at the first part, 7. The limit of 7 is just 7 because it will be 7 forever. Now the second part I have to look, 1 and 3x. Which one's greater, 1 or 3x? 3x is greater. The denominator is greater. So the answer, the limit for this second part is 0. Let's look at the last part. 2 over x squared. Which one's greater, 2 or x squared? X squared is greater. Okay? So if the denominator is greater, the limit is 0. The last part here is you just put them together with a plus and the minus following through. 7 plus 0 minus 0 is just 7. Next topic is one-sided limits. So if you see a little symbol with the plus as the exponent, that means from the right. When you see a little minus as an exponent, then you're going to say from the left. Okay, a quick example. Looking at this graph, what is the limit as x approaches -1? So I'm focusing on -1. And this is from the right. Next one is from the left. The last part is from both sides. When you don't see the exponent, it means from both sides. Okay, let's do it. So I'm looking at -1 from the right. So the right side comes from here. So I'm going to go stop there. It seems like my intended y value is 2. So that's my limit, 2. Now I'm going to do it from the left side. I stop right here. It seems like the intended y value is still 2. From both sides, do they meet at the same place? Well, we just got the same value, so they have to be meeting at the same place, and that place is 2. Okay, that's all for one-sided limits. Now we have a few AP problems here that I've collected for you, and we can try them. First one. Limit as x approaches infinity. We can't plug in anything right now, right? So we can't do direct substitution. What we can do is the concept of dominance, because infinity, whenever I see limit as x approaches infinity, that gives me a hint. We're probably going to use concept of dominance, because we cannot plug in infinity. Alright, so I know it looks kind of weird. Don't freak out. It's going to be the same steps. All you need to do is get rid of these parentheses, and mainly we have to look at the greatest one. So the greatest one here and here, all I do is multiply them. That becomes -2x squared. Do the same for a denominator, x and x, multiply them, that becomes over x squared. Everything else doesn't matter because they're smaller than x squared. Remember, we're focusing on the largest term when it comes to concept of dominance. Okay, so the exponents are the same, which means we have to take the leading coefficients and just divide it, which gives us -2. That's a limit. Next one, limit as x approaches 0. So the first thing I'm going to think about, can I do substitution? Yes, you can, but then you're going to get a 0 over 0. We do not like 0 over 0, so we have a few options here. We can either factor and cancel, or we can use L'Hopital's rule. I'm going to go with L'Hopital's rule. So I'm going to look at the numerator and take the derivative of it. So the derivative of 5x to the 4 is circle the exponent, bring it down, subtract 1. That'll be 20x to the third plus, do the same for 8x squared, 16x over, do the denominator. Derivative of 3x to the 4 is 12x to the third. You can do it step by step to get that. Minus, do the same for 16x squared. It'll be 32x. Pause here, make sure that you know where these values and derivatives are coming from. Okay, now if I stop here and I try to plug in 0, there's a problem. This still becomes 0 over 0, and we still don't like it. So we got to do L'Hopital's rule one more time, or however many times we need, so that we can get an actual value that is not 0 over 0. So we got to do it again. Same steps. Circle the exponent, bring it down, subtract 1. That becomes 60x squared plus 16. Do the denominator. Same steps. It'll be 36x squared minus 32. Now let's try this time. Let's plug in x equals 0, which we got from the limit. Let's see what we get. So that'll become 0 plus 16 is 16 over 0 minus 32 is negative 32. Well, this is not 0 over 0. We like this. This is an actual number. We can simplify this, and you're going to get negative 1 over 2. That is the limit. So let me say that again. We did L'Hopital's rule one time. It wasn't enough because we still got 0 over 0. So we did L'Hopital's rule again. Then we plugged in x equals 0, and we finally got an actual value. And we got negative 1/2. All right, next page. So here, I'm not going to go through the entire thing, but since it's the limit as x approaches infinity, that tells me that that is the concept of dominance that I have to apply. So please do the work, and you should get 1/4. If you don't know how to get 1/4, please refer to a peer or a classmate, or if they still don't know, you can ask me when I come back. All right? Next one. So this is still a limit problem from the AP exam. You're given a graph, and it says, the figure above shows the graph of a function f with domain 0 to 4. That just means there are x values from 0 to 4, and you can see that. 0, 1, 2, 3, 4. Okay, that's all it says. Which of the following statements are true? So we're going to go through each possibility and see if it's true. Ready? Okay. It says, limit as x approaches 2 from the left, this is from the left, exists. The next one is limit as x approaches 2 from the right, exists. And then limit as x approaches 2 from both sides exists. So we have to check, okay? So let's look at the picture. 2 is right here. From the left, yeah, there's a value there. So it exists. So you say yes or true. From the right, there is a value there. Yes, so it's true. From both sides, does it exist? Now, for both sides to exist, they have to meet at the same exact y value. Wait a second. They don't meet at the same exact y value. Okay? From the left, it ends up at this dot. From the right, it ends up at this other y value. So the limit as x approaches 2 does not exist. So this is false. Let me rewrite that. That's false. So only 1 and 2 are true. So let's find the option that says 1 and 2. It's right here. And we've answered that AP question. On to the next one. Number 79. So this says, for which graph here does the limit as x approaches 4 of f of x exist. So this is saying from both sides, they must meet at the same y value. Okay, let's try it. So let's focus at 4 here, at 4 here, at 4 here. Okay, from the left side, from the right side, they do meet. So yes, 1 works. So we're going to say 1 is true, it works. Okay, next one. From the left side, from the right side, yes, they meet. So we say yes for 1 and 2. Last one, from the left side ends up at this y value. From the right side, unfortunately, it's a different y value. So this one, no, okay? They don't meet, so the limit does not exist here. Okay, so let's choose our option that says 1 and 2. And we got it. So I have the problems from the AP review packet that I got you guys. I have them here, so you can redo the problems since now we can do it, okay? So for number 77, it says, for what values of a does the limit equal 0? So this means from both sides, they meet at 0 on the y value. So I'm not going to go over this example. I'm going to let you guys work through it, and you should get the answer 2 and 4, because at 2 and 4, from the left and from the right, they meet at 0, and also at 4. From the left and from the right, they meet at 0. Okay, 0 is right here. I'm going to put a line through here. Okay, next example. Limit as x approaches 3 of tangent x minus 3 over 3e to the x minus 3 minus x. If you do all of this, if you plug in 3, okay, so it'll be tan of 0 over 3e to the 0 minus 3, which will lead us, this will become 1. It'll give us 0 over 0. We don't like 0 over 0. This gives us a hint that we need to do L'Hopital's rule. Okay, so let me do that. The numerator, the derivative of tangent is secant squared x, but here it's x minus 3. Then I'm going to look inside over here. What's the derivative of x minus 3? It's just 1, so I just times 1 in the front, which is just nothing, so I can pretty much just erase that, because it'll be secant squared x minus 3 still. Now let's look at the denominator. Okay, so we have 3e to the x minus 3, that's still the derivative, minus the derivative of x is 1. Okay, so I'm going to plug in 3 and see what I can get here. For secant squared, I want you guys to remember that that's the same as 1 over cosine squared. So I'm going to plug in 3 minus 3 here. All over, I'm going to plug in 3e to the 3 minus 3 minus 1. All right, let's try our best. This is going to become 1 over cosine squared of 0. This is going to become 3e to the 0 minus 1. E to the 0 is just 1, so 3 minus 1, that'll be your new denominator. And a quick hint, the cosine of 0 is 1. So 1 over 1, okay, squared technically, which is still going to give us 1 over 2. Okay, so I know there was a lot of steps, but you can rewind this video and look through how I took the derivative of each, then plugged in again. so I can get the true limit value.